Good evening, students. So today we will continue with our last session, right? So we have started in last session the enterprise campus designing, right? So in this particular 3.2 we have started this enterprise campus design. There are a different requirements for your enterprise campus, right? The technology, cost per port, availability, scalability, and all that things, right? With respect to all the functional areas, whatever we have whatever we have seen in our this particular enterprise network design, right? Then also we have seen there are different access layer design considerations also, right? So with respect to the VLANs, right? So we are also discuss about what do you mean by VLANs, its feature, its types, and how to configure VLANs with the help of one a typical example of our laboratories, right? Then what are these particular Cisco STP toolkits also we have seen. What are the different Cisco STP toolkits are available that you need to use instead of that particular STP, right? So and if STP you don't not need to use, then RSTP if it is not available, then and then only you need to use that particular Cisco STP toolkit, right? Then in today's session we will talk about this our implementing this particular routing in our building access layer. Then what are the different campus core design consideration we have with respect to the size of the campus design, right? For example, the large campus design, or it having the small and medium size campus design. If you have, then what are the different consideration in each of the phases you need to consider, that also we will see. Okay, then we will see the age distribution at the campus layer core. As you know that this particular age distribution is nothing but one of the your functional area of your enterprise network, right? So with respect to the campus core, how it can be work, right, that we will see. Then server directly attached to the campus core. So how this particular servers plays an important role in the campus core, that we will see. And after that this particular servers in the server farm module, right? So server farm module also we have seen in our enterprise network as a function, one of the functional area, right? So that we will see in this session also, right? And what are the different guidelines for designing this particular server farm, right? So that also we will discuss. Okay, so today's session is the last session for this particular chapter number 3, right? Then your chapter number 3 will be over, right? So we will start with the this implementation of routing in the building access layer, right? So if you see in this particular diagram also, right, so there are a different one logical topology is there, and in this particular two switches I have configured one VLAN for my data and one VLAN for my voice part, right? And the same I have also implemented in this second switch as well, right? So here so if you are talking about this routing in the building access layers, right? So routing, then you must know the what are the different routing protocols, right? So that are covered in your chapter number 5, right? So I have listed some of the routing protocol. For example, I want to listed in EIGRP, one of the your routing protocol. Then OSPF is routing protocol, right? Then the static routing protocol also there, dynamic routing protocols. That EIGRP, OSPF is nothing but your dynamic routing protocol, right? So these are the some routing protocols that you need to consider while if you wanted to design in the building access layer, right? So obviously here also if you see here the we are using this particular routings in on layer 3, right? And on this particular router I am using this particular routing protocol to transfer the traffic or transfer the packets from one end to another end, right? So here if you see these this particular I am calculating the links for here. For example, here layer 3 is having the equal cost link, right? So layer 3 having the equal cost link, right? So why I am calculating the link cost of this particular all the links, right? So I need to set a or I need to identify a path, right, which having a minimum weight or a minimum cost, right? And and through that I am going to send my traffic, right? So it will be useful for calculating the base path from that particular network, right, from this particular access layer, right? And for that purpose I am able to use the routing protocol on that particular way, right? So there are some questions, right, so that you need to consider, you need to identify with respect to implementing the routing, right? So for example, what are the different building distribution switches you are using, right, for that particular topology, right? Or what are the different level of redundancies you are maintaining, right? For because of the level of redundancy only you need to calculate all the cost and all that things, right? So and also what are the different uplinks, how many uplinks you are using in your logical topology, right? And what is the speed of that particular uplink, and whether it will be attached to your core switches or what, then what type of the cabling you are using, right? So all these where you are having some IP telephony or some any IP multicasting options in your organization, right? So for that purpose, so you need to identify the other methodology, right, for routing that particular thing, right? Then also you need to understand the different networking characteristics also while implementing the routing in the building access layer, right? So what are the characteristic, if I need to take a name that, for example, the performance, right? So what are the performance of that particular building distribution layer switches, and how that particular performance of all the ports, right, which we are be working, right? And what is the speed of that particular ports, and all that things, and whether that particular attached to your campus core module or not, right? Or whether you are able to you have any plans for your the future expansion, right? So according to that you need to again use that additional ports or additional modules, right, in that particular designing layers, right? Then again a redundancy part also you need to think upon. Then what are the different redundancies you are using in your topology, so that the routing can be used neatly, right? Then what are the different infrastructure services you are going to provide, like I have listed now the IP telephoning, whether you are using teleconferencing, if you are using, right? Then at that time the QoS parameters will be very much important, right? Because of the high availability and all that things, it will be required for this particular IP telephony and all that things, right? So accordingly that you need to implement routing in this particular building access layer, right? So then if you see then again the next point is what the deploying the layer 3 routing protocols, right, between the building distribution and the campus core switches, right? So if you see here in this particular diagram also, right, so I am giving you two examples here, right? So for deploying layer 3 routing protocols, right, in between this building distribution and the access layer, right? So we have one triangle redundancies over here, and the square redundancies is over, right? So if you so if you see in this particular diagram, right, so the multi-layer switches, right, so which we are connecting with all the redundancies with this particular triangle switch, right? So if you see here this particular from this particular switch to this this particular router to this particular router, and this is nothing but your triangle, the arrows you are seeing here, right? So it is having some triangular connectivity, right? So triangular redundancies will be there, right? And for example, if one of the links of this particular distribution layer device, if it is failed, right, then what is the whatever the convergence time, right, which will be very very fast in this case, right? Because whatever the failure whenever the detected, right, so it will be detected obviously in the hardware, right, in the devices, right? And therefore there is no need for this particular routing protocol whatever we are going to implement on this particular internet networking components, right? So there is no need for this particular routing protocol to recalculate the new path, right? So it just continues to use one of the path already in its routing table, because whenever you are using this triangular redundancies, right, so all the paths is already there in the routing table. So if one path is failed or one link is failed, right, so this convergence is very much fast, right? So whatever the there in the routing table, it will be directly switch into that particular path, right? But if you see in this particular square redundancies part, right, so here only one path is active by default at a one time, right? And if a link or device is fails in this particular square redundancy as well, right, then this particular that particular routing protocol needs to recalculate all this particular new route, right, to send the traffic to a next level, right? So therefore the convergence time will be very more, right, in this particular square redundancies part, right? So we always suggesting this particular triangular redundancies must be there instead of this particular square redundancies, right? Because if any internet devices, any devices is having some failure, or any link is down, then there will be more time will be required instead of this particular square redundancies, right? So in order to calculate the cost of that particular link, right? And whenever we are implementing any routing protocol under any kind of the topology, right, so we always see to the different alternatives, right, or different minimum path which will be having, and then we are going to send the traffic to that particular path, right? And the main requirement is the convergence times will be very less we want always, right? Because then and then only our communication will not hamper, right? And we have an 24/7 and availability, right? And that's why we are called it as an your reliable network, right? So these points we need to be take care, okay, in this particular campus core design layer and the service layers, right? Then we will see the campus core design considerations, right? So here we will see with the type, or with the some of the distinguishes in between the large campus design, small campus design, medium campus design. What are the different considerations you need to check, right, or you need to consider, right? So if you see whatever the campus core you are designing, right, so at that point you need to check the what is the low price per port is there, what are the high port density will be there, right? So whether that particular switch is having all this capability in that particular environment, right? So where multi-layer switching you are using, where layer 2 switching you are using, right? What are the number of connections in between this particular building distribution layer switches is having, right? And how that particular integration can be take place with the help of that particular server farm model which we are using, and the enterprise edge model. These are nothing but the parts of our these functional areas of enterprise network, right? So these also you need to consider while designing this particular campus core layer, right? Then if I wanted to list out again, for example, what is the speed forwarding for all the interfaces which we are using, right? So what is the performance for each and every port, right? So and whatever densities you are using for that particular port, right? So that you also need to calculate, okay? Then scalability, what is the scalability at your campus core layer, right? So in network requirement also we have seen the scalability for your campus core layer and the server farm layer, which will be very low, which must be very low. Why? Because in campus core we are campus core is responsible for your what high level switching, right? And for the building distribution and access layer you may have high scalability, right? Because at every time you can adjust or you can change it according to organization requirements, right? So for example I wanted to give then for example the new building distribution switches, right? So whatever we are using, that connectivity will nothing but the full mesh connectivity, right? So each and every internet devices have a different link redundancies over there, or over that particular building distribution layer switches, right? So in full connectivity, if you are using in campus core, right, then these all the considerations you need to take care, right? So but by doing all these things, right, so you need to consider some of the issues, right? For example, the performance, what will be the needed by that particular campus core network, right, that you need to analyze, right? Then next one is what is the number of high capacity ports if you are using for building distribution layer aggregation, right? Then you need to check this particular connection to that to the server farm module or the enterprise edge module, right? So the connectivity in from that particular building distribution layer building distribution layer and the server farm and enterprise edge module, that also you need to check, right? And the third one is if I wanted to talk on the reliable network, right, then the high availability and redundancies, right? So we have also already studied what are the different types of the redundancies we have, right? The port redundancies, link redundancies, power redundancies, right, path redundancies, route redundancies, and all that things, right? So all the requirements of that particular high availability and redundancies, right? So you need to provide for each and every switches a different kind of the techniques, right, in order to get a connectivity to this particular campus core enterprise edge network connectivity, right? So if I'm considering this particular large campus network, right, so large campus network, right? So you so some of the best practices you need to check, right? So for example, whether you are using in this particular large campus network the multi-layer switching is there or not, right? Or whether this particular topology whatever you are using for this particular large campus network, right, it having some no spanning tree loops or what, right? Because obviously you are using you are not using this STP, right, in any kind of the campus core or any kind of the distribution layer, right? So you are obviously you are using this layer 3 switching, so multi switching will be there. So in that thing you need to check that particular broadcast controlling, and you need to provide all the multicasting support to that particular large campus designing, right? Then also you need to think upon this particular network infrastructure services whatever you are providing, right? So you need to give its supports, right? For example, I want to give for example, then what are the multi-layer campus core switches you are using, right? So it obviously it will be providing you the high intelligent network services, right, because it's in an multi-layer switching, right? So whatever the network services you are going to use, right, so that will be provided by that particular data link layer core layer switches, right? Then this particular whatever the designing you are creating, right, so each and everyone having some link redundancies over there, right? So for if any link failure is there, then it should be fast recovery will be possible if you are using this particular link redundancies over there, right? Then you can also use that particular access list ACLs you can use for giving the high performance or giving some of the security level to that particular large enterprise campus, right? Then you can use this particular ACLs and security level hardware security level perspectives, right? Then after the large network, if you see this small campus and the medium campus network, right? So whenever if you talk about with the number of end devices if you are using, right? So for example, whatever the small campuses network you are using, right, so which having some less than the 200 end devices, right? So and the network servers, or you can call it as workstations, right, which will be connected to the same wiring closet, right? So it will nothing but your small campus network, right? So and if it is and more than 200 and something end devices, but less than 1000 end devices, right, then it will be your medium campus network. And if it is more than 1000 end devices, then it will be your large campus network, right? So whenever so whatever the switches you going to use in this particular small campus network, right? So it may have some high end switching performance or this different scaling properties also, right? But but in this case, this particular building distribution or this particular campus core, right, you have only one single layer in this particular small campus network, right? Because you have only limited to 200 end devices, right? So there will be no any we can call it a hierarchical layer model is designed for this particular small campus network, because there is no need such a, because in distribution and the core layer itself, directly you can attach it with your access layer end devices, right? So there will be no any differentiation in between the building distribution and campus core if you consider this particular small campus network, right? But if you have more than 200 and less than 1000 in devices, right, so that is nothing but your medium sized campus network, right? So in these this particular network infrastructure, right, whatever you are using, so in that you can you may have this particular different access layer different switches, right? And the building and sorry, distribution and the core layer, you can have a one single layer, and for the access layer you having a different access layer switch, and after that it will be connected to your the server farm module, right? And obviously in this medium campus network, you need to provide then the redundancies, right? So redundant multi-layer switching will be there, which will be connected to this particular building distribution layer switches to this particular access layer switches, right? And it will having some full redundancies part. So these are there in a medium campus network, which will be not a part of your small campus network, if you see, right? So there is a difference in between the large campus network, small campus network, and medium campus network, right? So if your end devices, and it will be depending upon your end devices, right, which we are connected this particular network. So if it is less than 200, then it is a small campus network. If it is in between the 200 to 1000, then it will be your medium campus network. And if it is more than 1000 end devices, then it will be nothing but your large campus design, right? So in each and every one thing is having a different perspectives, right? So if you see in large campus network, so there are, it will be divided in multi-layer switching is having in different parts, right? And also it having using a different interconnected devices in each and every layer, and also the redundancy is also maintained in each and every layer of this hierarchical enterprise model, right? But it will be absent in this particular small campus network, because there is an no need for this separate access layer switches, and then multi switching in between the access and the building distribution, and the link redundancy and all that part, right? Because it having only a 200 less than 200 and end devices, so it will be easily managed by this particular building distribution or campus core layer itself, right? And if you see in this particular medium campus network, so we must have there is a different building distribution and the access layer, and obviously the multi-layer switching which will be having, and the link redundancy we must have in between this particular two switches, multi-layer building distribution core and access layer, right? So it will be nothing but your medium campus network, right? Then we will have this particular edge distribution at campus core model, right? So you already know this particular distribution edge distribution model we have already seen, because this is nothing but one of your functional area of this particular enterprise network, right? So it having some of the sub modules. These are already we have studied. For example, if you consider this e-commerce model we have, then ISP, internet connectivity model we have this WAN and MAN side to side VPN we have, then remote access VPN we have, right? So these all these sub models together we will call it as an enterprise edge model, right? And if you see here, it all these modules, sub modules are connected to this particular campus core layer, right? So which having some of the core core layer switches, core layer routers, right? So then these are some access layer switches and routers are there, right? And there is an link redundancies over there in these particular devices, right? And each and every devices is which we are connected to this particular enterprise edge submodules, right? So this is nothing but the edge distribution design, right? And so here, if you see in edge distribution switches, right, so it will be responsible for your filtering part, right? Filtering, and it will be also, if you see in the diagram also, right, so whatever the route traffic is there, right, so it will be into your campus core layer, right? And it obviously it aggregates all the enterprise edge connectivity, right? And all the services which this particular sub modules is giving, right? So that you are going to provide in a through the campus core layer, right? So here the switching speed is not that much of important, right? Because it's that in this particular enterprise edge model, that the security will be very much crucial, right? Because if you see here, that isolates and this particular it controls actually the access to that particular devices, right? Because which are already located in a different edge enterprise edge model, right? For example, if you see, I want to, for example, give the example, then this particular e-commerce model, right? So e-commerce may have some public servers, right, and which will be connected to the internet connectivity module, right? Then obviously that part, the switching speed is not requirement, right? But the security part is very much important, right? And to protect all these particular campus core, right, from that the particular external users, right? So therefore we are introducing here the high risk to that particular internal campus, right? So to protect this particular campus core, right, from the threats that switches in the edge distribution model, we must protect this particular campus from the different kind of the attacks, right? So that attacks also we have seen in previously, so I'll just revise that attacks, right? So what attacks we have seen, I think there are 4 types of attack, right? Unauthorized access also there, IP spoofing also there, then packet sniffing is there, then network discovery for the different kinds of the attack, that is also there, right? So we will see one by one. So in unauthorized access, if you see, right, so whatever the connections from that this particular edge distribution model, right, it will be passes through this particular campus core, right? And these whatever the packets will be transferred from this core model to this particular this particular edge model to this particular campus core, right? It must be verified, right, against the, all the users and the user rights, right? So there must be some filtering mechanism, right, which controls over this particular edge subnets and their capabilities, right? So there must be some verification kind of thing is there to protect from the unauthorized access, right? So that is a one part, right? And then the second one is your IP spoofing, right? So you already you know what you mean IP spoofing, right? It is a hacker technique for impersonate the identity of another user by using the its own IP addresses, right? So it may arise DOS attacks, right? So it can be used IP spoofing for that, right? So in DOS attack, what happened? So it generates requests from the servers and continuously utilize that all the services, right? So the result is that particular service is unavailable, right, to all the users, right? So it will nothing but the IP spoofing, right? So the attacker can use internal IP address, right, for the source IP address of that particular packet to produce this kind of the attacks, right? So it's called as an IP spoofing, right? Then network reconnaissance, if you see, it is nothing but the network will be used for the discovery part, right? So whatever the packets you are sending into that particular network, right? So it obviously it collected all the responses from that particular internet networking devices whatever we are using, right? And these particular responses which will be provided all the basic information about the internal network topology, right? So these are the some methods that particular network intruders can use to find out the different networking devices whatever the uses and what are the different networking services that run on that particular network, right? So this is the method to get the information about internet networking devices and different networking services, right? So and the next one is your the packet sniffing, right? So the packet sniffers nothing but are the devices, right? So which will be able to monitor and capture the network traffic, right? And it will be again used by some of the hackers, right? So the what are the packets which we are belonging the same broadcasting domain, right? Which are vulnerable and to capture the packet sniffer, right? So these kind of the techniques will be used to get all the kind of the information, or it continuously monitor and capture the traffic which we are flowing from your network, right? And it will be analyze it, right? And then it will be used by that particular hackers to harm your kind of the network, right? So these kind of the attacks are available on this particular edge distribution, and that you need to provide the security to your network, right? And in order to provide the security, that you need to add a security layer in your distribution edge distribution layer, right? So it is very much important thing, right? Then we will see this particular servers, right? So which are be directly attached to this particular campus core, right? So so if you see whenever the servers are there, right? So we are having some of the characteristics of any kind of those servers. If you see, then this particular policies whatever we have, or the rules whatever we have, right? So we always incorporate into this particular building distribution layer switches, right? So if you see in this diagram also, right? So each and every internet networking device is having a link redundancies over here, right? If you see in campus core to this particular building distribution, in building distribution is also having some link redundancies, right? From building distribution to the access layer is also having some link redundancies, right? But in this particular building distribution mainly we have we have some policy based control, right? For accessing all these kind of the servers, right? Instead of this particular campus core. Why? Because the campus core whatever we are using, right? So it will be mainly responsible for the high end switching, right? Then whatever the policies and protocols we need to maintain in our network, right? So that we are apply on this particular building distribution layer switches, and from that you can manage or you can access this particular building access layer and from the end devices, right? So you already know that that VLAN concepts we have already seen in our last session, right? So that also you can be managed through this particular building distribution layer switches, right? So security parameter, management parameter, or QoS parameters, right? Whatever we have, availability and all that things, right? So that you need to manage from this particular building distribution layer switches only. So whenever the servers which are directly or indirectly attached to this particular campus core, or in any kind of the network, right? Either it is medium or the large, right? You need to apply all the policy based parameters to this building distribution layer, right? So that this you need to take care. Okay. Then we have this particular servers in a server farm module, right? So if you see in this particular diagram also, right? So whenever any kind of the large organization or any kind of the large server deployments is there, right? So now you need some you must understand first about the what is the requirement of that particular different kind of the servers, right? And these particular servers you are using is for the which functionality or which purposes, right? That you must understood first, right? And you already seen all the enterprise edge model, right? So in that also we have that e-commerce model, we have that ISP and all that things, right? So in that also the database server, the web server, the DNS server, so all these are we are using, right? But you must know what is the purpose of all these things, right? And how you are going to consolidate it, all this part into the different server farm model, right? That you need to check, right? Uh, because of that particular all the enterprise edge model having very heavy traffic load, right? So the servers which we are using, right? So which have generally or usually having some gigabit ethernet that will be attached to this particular server farm model, right? Because obviously it will be also a very crucial part of any kind of the organization, because any type of the organization is having some critical applications over there, right? So which will be directly depending upon that particular server farm model, or it will be directly attached to this particular server farm model, right? So if any failure will be there, then it will be directly impact on that particular critical applications, right? And because of that only we must have some link redundancies over there, right? And because of this particular high switching capability of enterprise core, we have that directly attachment to this particular server farm model, right? So this will help us to provide the high availability and reliable network, right? So this particular server farm model which we are showing seen in this particular diagram, right? Which having some server to server traffic to this particular campus core as well, right? So this is one of the important point with respect to your reliable network, right? Because it having some availability, scalability, then throughput, the security, then all these kind of the QoS parameters, right? Whatever you have, that you must be understood, or you must be seen in terms of your this particular server farm model, right? Then then we check this particular sample server farm model, right? So whatever the servers you have already, so this particular I already discussed right away, that this particular server farm model is connected directly with your the campus core model, right? And there is and must have some link redundancies over this campus model and the server farm model, right? Because if you see the functionality of this particular campus core model is nothing but the high switching, it must provide the high switching, right? And by providing this high switching to the server farm model, it will be help us to use this all the critical application whichever the organization is having, right? So it will provide that particular application the high availability, right? And the scalability as well, right? Because of this particular high switching. Okay, so so there are different ways to connect in between these particular servers, right? So for example, you can a server can attach by one or two fast ethernet connection, right? So we already seen there is an concept called as NIC redundancies or physical redundancies, right? So we may have different NICs, one or two NICs would be there, or we can have some multi-port NICs into this particular servers, right? So it will be we can have this in a server farm model, right? To or we can have this particular server itself, right? So dual NIC we can call it as, okay? Or we may have some VLAN or any kind of the ACLs if we use, or we have some different kind of the policies for that particular server farm module, right? Then it will be very much useful for in terms of the security of view, right? And whatever the switches, right? So which we are using in this particular server form module, right? So the load balancing of that particular user request across this particular server form module, that also is having one major impact, right? Because it will provide then the optimal performance. It must have some scalability, it must have some content availability and all that things, right? So if you see in our college also, right, so we have some different kind of the what we can call proxy servers we have, right? So we have an two different proxy servers, right? So if one proxy server is down, then we have an alternative of that particular to that particular proxy servers, right? So with the help of all these things, right, we are check the scalability and the optimal performance of this particular server form module, right? And this is one of the sample that how this particular server farm is module is there, and it will be designed, right? So this is all about today. So what we have covered today in this lecture. So we have started with the routing, implementation of routing in the building access layer, right? So for that you must know what are the different types of the routing, right? The static routing, dynamic routing, what are the different routing protocols are there, right? And which routing protocols will be useful for which layer, right? So that also you need to understand, right? Then some of the routing protocols we need to study in our next chapter, right? So from that also you come to know how this particular routing protocol will be used in each of the different layers, right? Then we start with this campus core design consideration with the different types of the campus core design, right? For example, the large campus, then small campus, and the medium campus options, right? And we have shown how we can be distinguished in between these. If you have less than 200 and n devices connected with your core network, then it must have it is nothing but the small campus design, right? And if it is in between the 200 to 1000, then it will be called it as a medium campus design option consideration. Or if it is having an 1000 and more connecting end user devices, then it will be called it as an large campus design, right? Then we discuss about the edge distribution at the campus core, right? So we have this particular edge distribution functional area in our enterprise network, right? So with respect to that, how this particular edge distribution will be connected to your campus core layer, and what are the different attacks are there or can be happen in this particular edge distribution to campus core, right? So unauthorized access is there, sniffing is there, spoofing is there, and all that things we have discussed, right? And then how this particular servers which we are directly connecting to our the campus core, right? So link redundancies, uplinks, and speed of that particular switching, high switching, and all that things we have discussed, right? Then what are the servers in a server form module, right? And how it will be connected to your campus core layer, that also we have studied. And one sample server form design also we have discussed, right? So this is all about today. Okay, so in this way we have finished our chapter number 3 in this particular lecture, right? So from next lecture we will start with the chapter number 4. Okay, so this is today's link, so you must go with the link. Okay, answer all the questions. Okay, so we will stop today. Okay, so we have chapter 4 in our next lecture, right? Okay, thank you for joining.